Alright guys, in this video we're going to take a look at solving for endpoint. So up until this point we've done midpoint. We're going to look at distance. After this we do endpoint, but endpoint is kind of connected to midpoint. So let's kind of look at what happens graphically, and then we'll talk about the algebra. So let's look at this problem here. We're given the midpoint of 0, 1 and the endpoint of -4, 1. So what we want to do here is we want to find the other endpoint. So when we do midpoint problems, it's not necessarily stated this way, but you're given two endpoints, right? You have a line segment, two endpoints, and what you're going to do is you take those 2 points and then you average them out to find the middle of those two endpoints. Well, now instead of having two endpoints, they're going to give us an endpoint and a midpoint, and then we have to go and solve for the endpoint. Now we're going to look at two ways: graphically and algebraically. So let's look graphically, kind of see what's happening here. So let's start by graphing my midpoint and my endpoint. One of the keys, if we're going to solve this algebraically, is making sure that you label your points. Otherwise you don't know when you're looking at a graph which one is the midpoint, which one's the endpoint. So let's go ahead and graph these at 0, -1. That puts me right here. And I'm going to put an M here for midpoint. And then -4, 1, 2, 3, 4, +1, that puts me here. Now, like I said, a common mistake is to not label them, and instead of getting a second endpoint where the midpoint is in the middle, they get the midpoint and the endpoint confused. So let me show you how to solve this one, and you'll kind of see where you might go wrong. So if this is one end and this is the middle, what I need to go is the same distance that I took from the endpoint to the midpoint to get to the second endpoint. You can think of it a little bit like if you're going on, say, a 4-hour car drive, and you drive out, say you're just going east, you're on the east and you're headed west 4 hours. Say you go 2 hours, you stop. Well, now you're at the midpoint, and then you still need to do another 2 hours continuing to the west. So same thing here. Whatever we did in the first half, from the endpoint to the midpoint, if I can just duplicate that, then I can go ahead and find my second endpoint. So what we're going to do is we're going to think about our movement in terms of verticals and horizontals. So how far did I move from my endpoint to my midpoint? Well, I moved down 2, and I moved to the right 4. Okay, so I went down 2 to the right 4. So I'm going to do the exact same thing here. I'm going to go down 2 more boxes from my midpoint, and to the right 4 boxes, 1, 2, 3, 4, and that puts me right here. Notice I'm just taking whatever I did to get halfway. If I do it a second time, I should get to the second endpoint. And then what is my point on the graph? Well, my point there is at 4, -3. Remember, we're not using the 2 and the 4 as my final answer. We're just using it to get to the final answer. Where is this second E point on my graph? Well, it's at 4, -3. And so you can kind of see where you might go wrong. If the midpoint and endpoint are switched, you're going to end up going up and to the left instead of down and to the right. So make sure you label them if you go with it graphically. So this kind of shows you what's happening. Now let's talk about algebraically, because we don't always want to graph every single endpoint problem we get to. So let's take a look at another example. Now I know this looks like a lot, but let me kind of explain it. This is kind of more notes than anything. But let me kind of show you what's happening here. We have a midpoint of AB at 3, 4. And we have an endpoint at -3, -2. What we want to do is we want to find the coordinates of the endpoint B. So we're going to use our midpoint formula. Remember, our midpoint formula looks something like this. X sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 all over 2. And sorry, this is a little sketchy here. There we go. And that gives me some midpoint. And what I'll call actually is, I'll call it x sub m, y sub m. That is tough to read. Let me see if I clean that up a little bit. X sub m, m for midpoint, y sub m. And again, not great, but you get the idea. The main point here is we take two endpoints, we plug them into the midpoint formula, and it spits out a midpoint. Now, I don't have two endpoints, I only have one endpoint. Notice here at -3, -2. So notice what we do is we still plug the -3 and the -2 into my formula for midpoint. But notice what I do with my midpoint. I don't plug it into where the endpoints go. Remember, normally I plug 2 endpoints in and it spits out a midpoint. In this case, I'm going to plug in 1 endpoint and I'm going to plug the midpoint where the midpoint goes. Notice we kind of treat this as 2 separate equations. We add the x's divided by 2, we add the y's divided by 2, and it should give us a midpoint value. Now notice here we put the midpoint on the outside for both of these. Now I only have one variable left. I have my x sub 2 and my y sub 2, and that's what I'd like to solve for. So what I'm going to do is I'm going to use some algebra here. Let me back this up. I'm going to use some algebra here to solve. So I know that 3 is equal to -3 plus x sub 2 divided by 2. So the first thing I'm going to do is I'm going to multiply by 2 here on both sides. So I get 6 is equal to -3 plus x. I'm just going to call it x, but x sub 2 is technically right. We're just going to add 3. What do I end up with? X is equal to 9, or x sub 2 is equal to 9. Now let's do the same thing here for 4. I'm going to multiply both sides by 2. I get 8 is equal to -2 plus y sub 2. And again, actually, let's just go with y on that one. 8 is equal to -2 plus y. And let's add our 2 on both sides. And we get 10 is equal to y. And so my final answer here is 9, 10. Now, you might be saying, this is point B. B is equal to 9, 10. Now you might be saying, well, that seems like a lot of work. Why can't we do all of them on the graph? Well, it would be nice, but some of these problems you end up getting really large numbers. You have to count all these boxes, or maybe you don't want to graph. So this allows us to solve it for any problem that we run into. And remember, your final answer needs to be in the form of a point. You can't just say it's not x is 9, y is 10. You need to put it back because my final answer is an end point. So that word point implies we're going to have an x value and a y value. So that was kind of getting down into the nitty gritty. Let's do one last problem just to see how this works. We'll move through it a little bit faster. Hopefully it'll be a little clearer. So first thing I want to do is I want to plug in my endpoint. So I know I've got -6 plus some x value divided by 2. And I've got 17 plus some y value all divided by 2. And that should spit out a midpoint, which I know is 7, and my midpoint, which is 0. Now, keep track. Sometimes places will kind of switch if the midpoint or endpoint comes first, so you do need to read the problem to see which one is my midpoint, which one is my endpoint. But my midpoint always goes outside here. So I'm going to multiply top and bottom by 2, and so I get 14 is equal to -6 plus x. I'm going to add 6, so I get 20 for x. Let's do the same thing over here for y. And once you do one or two of these, you start to realize that these all kind of work the same way. And we're going to subtract 17 on both sides. And so I get -17 is equal to y. And so my final answer here is 20, -17. And this would be my other endpoint, 20, -17. So hopefully this wraps it up. You're going to go ahead and do the IXL on endpoint, and that should get you enough practice that you feel good about it. Also, we are looking at having an assessment at the end of the week, wrapping up distance, endpoint, midpoint, and some of our geometry terms and angles.